Hello everyone, this is Maokui. I'll first talk about TSVD on the diarization part of Nibri CSS. Then Yanhui will introduce diarization-based speech separation. Finally, Ni will present hybrid acoustic modeling. The whole work is more like Chami pipeline than diarization is first, and followed by separation and recognition. Now let me introduce the first part. As we all know, the baseline diarization that performs clustering on X vector couldn't solve overlap segments. Do resegmentation on the detected overlap segments is a solution. TSVD provides another solution by directly predicting all of speaker appearance in a session on the frame level, but would it work on LibreCSS? TSVD works on CHAM6 where initialization DI is around 50, while LibreCSS baseline diarization DI is around 20. That makes it possible. However, without training data and uncertain of speaker number may be the problems. The red figures show the single-channel multi-speaker TSVD. Here I change the output speaker number from 4 to 8 to make it possible that we can correctly detect all of speaker in LibreCSS, because the maximum session speaker number in LibreCSS is 8, while it's 4 in CHAM6. I focused on single-channel multi-speaker TSVD, because TSVD benefits from multi-channel information in CHAM6, while the LibreCSS microphones are close to each other. So I don't think it will benefit from the multi-channel information. The next slide shows that the experiments show that simulation Libre CSS styles data for training is important. That means each session contains 8 speakers, and each speaker in the session contains 6 to 9 Libre speech sentences. Overlap ratio is 0 to 40%. The whole training set contains about 5,000 sessions and near 1,000 hours. Each speaker I vector is estimated with non-overlap speech in one session. It means we treat single Libre speech speaker as different speaker in different simulated session. This shows better generalization than directly extracting I vectors from Libre speech, and the label is generated by the first alignment of Libre speech sentence. The next slide is for the decoding part. For decoding, the problem is we didn't have Oracle speaker number. It's totally depend on the initial diarization results. We chose 8 longest speech speaker when speaker number is more than 8, and appending training set speaker I vector to 8 speaker, while speaker number is smaller than 8. To using TSVD predictions to get more reliable I vectors, we first exclude non-target speaker frames by absolute threshold, and then exclude overlapping frames by multi-speaker threshold. Finally, calculate I vectors using the resulting frame width. The post-processing includes median filtering, thresholding, deleting two short segments, and combine speech segments separated by short pauses. The next slide shows the results on LibreCSS. The former mentioned post-processing parameters are tuned on development set. Here I use 2 different labels to tune best DR. Sorry, the 7 slides. Yeah.
This is 7.
Yeah. The utterance, I use 2 different label to tune the best DR. The utterance level label is just than 1 to the whole target speaker utterance, and the word level label is only a setting 1 to each word located by false alignment. And the 2 different initial diarization method, VB and spectral clustering, is used for decoding. The baseline acoustic model and language model rescoring is used for evaluating ASR performance. The results show that TSVD tuned with utterance label gives the better ASR results. Might because word level setting needs too many short segments. It harms recognition that needs context information. With two different initial segments, TSVD improves the diarization results, but better initialization leads to better diarization and ASR results with the utterance level setting. And finally, the best WER results of TSVD are close to those of ASR with oracle segments. The next slide shows that the next slide, please. To say what will happen when speaker number, sorry.
Oh, I already did that. I think you have some lagging.
Oh,
Yeah.
sorry.
Right.
To say what happened when speaker number is smaller than the designed, I tested the same model with LibreCS ad hoc. It contains two or five speakers in a session, and the other setting is similar with the LibreCSS. The results show that TSVD also improves the diarization and ASR results. Yes. The next slide shows the release quality pipeline of TSVD include the whole decoding part and the pre-trained model. So welcome to try it and communicate with me to solve the problems. Yeah. To the next slide. As we can see, there are still much work to do. We can perform viewing on different initial segments. For example, VB or spectral clustering or other derivation method at the with the TSVD output probabilities, and there are and more analysis and how to choose the label in different tasks. Utterance level label is better choice in ASR, but when it comes to other applications, word level label may be the better ones. And there are also two different pipeline combining separation we can try. For example, separation before diarization or diarization before separation. And Yanhui will introduce the second pipeline. Yeah, that's it.
Hello everyone, my name is Yan Hui. I will introduce the multi-channel speech separation based on the diarization for the long meeting recognition task. And here is the framework of the diarization-based speech separation, as shown in the figure 1. And we firstly get the segments information marked in different colors from the diarization results introduced by Mokui. And here different colors denote the segments information of different speakers, and N is the number of the speakers during a non-meeting case, and M is the total number of the segments. Next, as shown in the figure 2, each segment SM is extended with extra several seconds speech on the left and right. And then the extended segment is utilized for CSCGM-based mask estimation. And finally, the estimated mask is adopted for GVD beamforming. And you can find the details in the reference 1 and 2. And here is the experiment. It is our experiment, and for the diarization, and we use the Mokui-based configurations on the utterance level, and for the speech separation, the CSCGMM with 9 classes and 8 speakers and one noise, and also 10 seconds for extra speech on the left and right. And the GEVD is used as our beamforming. For the recognition, and the acoustic model is the baseline AM, and for the language model, we use the RNLM. And here are the results on the development and evaluation sets of the shoot in the table 1 and table 2. We can find that the DSS-based method can improve the performance on the non-overlap 0L and 0S, and also the overlap cases. The DSS-based method achieves about an average relative WER reduction of 35% comparing to noise. And the next, here's, also finally we give 2 examples to show why the DSS-based method can get better performance on the non-overlap and overlap case. And the left here is the non-overlap case, and we can find the DSS-based method can eliminate the background noise and also improve the SNR levels. And for the right is the overlap case, and we can find the DSS method can remove the interference speech well, and to decrease the insert errors for recognition. Okay, and for the future work, we will explore 2 aspects. One is the iterative DSS pipeline, and we can use the first diarization and for the speech separation, and also the separated speech also can do diarization again. And another is to utilize single channel speech separation to optimize CSCGMM-based mask estimation, because for the current version, the initial mask from the diarization is on the frame level, and for speech separation, it can provide the mask on the time frequency level. And next, and Yichai will introduce the recognition work on the workshop.
Okay, just a moment. There's a quick question. Maybe it's for either Yanhui or maybe June. Paula Garcia asks, any thought on how to make TSVAD work for an unknown number of speakers? I know you showed us that you trained for 8 and you had either 2 or 5. Do either of you or June, do you want to answer the question now? What would you do if you didn't know the number of speakers?
Maybe I can do the
Go ahead, Marco.
Okay.
Oh yeah. I think I have explained in my slides. My solution is depend on the initial derivation results. For example, the X vector plus spectral cluster. With this result, TSVD can load the input speaker number and do the decode with what I said before. The other ways, I tried the single speaker TSVD, which takes only one speaker at one time, but it doesn't perform better than I mentioned before. Yeah, I think TSVD works when the session speaker number is smaller than the designed. Well, yeah, that's it.
Okay.
Can you continue? I think I can still do the switching of the slides for you.
Right.
Hello?
Yeah.
Yeah.
June, go ahead.
Yeah, I can
That's
try.
great.
Yeah.
Yes.
Okay. Yeah, but I have no rehearsal yet, so I will try my best to
Okay.
give this. Okay. Next slide. Okay. So for this part, we just want to compare several different acoustic model structures. Yeah, because this several new architectures except the TDNF we have tried on CHAM6 challenges, so it gives better results. So we want to retest it on the LibreCSS tasks. Yes, and our current setting is we use LibreCSS data to train it, and with data augmentation, yeah, using the speed and the volume perturbation. Yeah, this is acoustic model structures. Yeah, so actually we have a paper, but we do not cite it here. So maybe we will you can get some more information in the papers. Yes. So I will not introduce all the details here. So I can move on to the next slide. Yeah, to show the result. This is use baseline pipeline here. You can see that here we do not use TSVAD. You just the baseline. Yeah, we can see that all the three models can get better results, and the best one is the ResNet plus the TDN and plus the REST by LSTM setting. Yeah, gets the best result. Okay, next slide. Yeah. On next slide, we tested on the TSVAD. Yeah, so the baseline is much better now, and also we can get the improvement on both the Oracle segment and the diarized segments. Okay. Actually, this is setting is conducted on the mock quiz, the first part, the TSVAD, but without the separation. So next slide. Yeah. Next slide, we actually is our current best setting of the front end. We use both diarization with TSVD and the separation with DSS described by Yanhui. Yeah, and we have the best baseline here. Also, we get some improvement. Yeah, but for this setting, our best setting, our best result is the second one, is to use the ResNet self-attended TDNF, because I'm not sure, because the result of this page is just updated just 1 hour. Yeah, then so I'm not sure the result is accurate here. So yeah, but I think the improvement, the trend is similar to the previous two previous two slides. Yes. Okay. Next slide. Yeah. Finally, we get some talk about some future work. Yeah, future work. We want to compare our hybrid course model with end-to-end models such as ESP.NET. Yeah, we want to make some comparison between the hybrid model and the end-to-end model in the multi-talker scenarios. Yes, we think that actually not only just on the LibreCSS setting, we also want to compare on the CHAM6 challenge. So this is our future work. Yeah. Okay. Thanks.
Thank you. Thank you for the presentation. Yeah. According to the agenda, we will have 5-minute break. Oh, by the way, is there any questions?
Questions from the audience, please. Anyone?
Yeah.
Ivan is asking, what's the difference between DSS and GSS?
Yeah, we actually replied to our panelists. It's not to all, so probably Jun, you can read it.
Yeah.
Oh.
Okay.
Okay.
Yeah.
Yeah. Hi.
Jun, just say your answer. Yeah.
Yeah. Can you hear me?
Yeah.
Yeah. Okay. Thank you. Hi, Ivan. Thanks for your good question. And the DSS is just inspired by the GSS, and only the beamforming is different. And we just want to reproduce it on the LibreCSS dataset. Okay.
Yeah, I think here the DSS is to, I want to emphasize that we use the diarization first. Yeah, because in CHAM 6, for the task 1, the GSS is applied on the Oracle segments. Yeah, here DSS is applied on GSVD diarization. Yeah,
Okay.